To determine the ampacity of type NM cables, as referenced in National Electrical Code Section 334.80, one must refer to Section 310.15. Within this section, Table 310.16 provides crucial information regarding temperature ratings and ampacity for conductors, including NM cables. This table lists the allowable ampacities of insulated conductors rated up to and including 2000 volts, and it's essential for selecting the correct size NM cable for a given electrical load. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously under specific conditions of use without exceeding its temperature rating. Selecting the appropriate ampacity is crucial for electrical safety and preventing overheating, insulation damage, and potential fire hazards. Table 310.16 is organized based on conductor temperature ratings, typically 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. NM cables are generally rated for 90 degrees Celsius, however, Section 334.80 restricts the ampacity to that of a 60 degrees Celsius conductor for cables rated 100 amps or less, or 75 degrees Celsius for cables rated over 100 amps. This is due to the limitations of the termination points within typical residential and commercial electrical equipment. It is important to consult the equipment's listing to determine the termination temperature rating. For example, a 14 American wire gauge NM cable is typically rated for 15 amps, a 12 American wire gauge NM cable is typically rated for 20 amps, and a 10 American wire gauge NM cable is typically rated for 30 amps when used in accordance with the 60 degrees Celsius column of Table 310.16. Remember that these are general guidelines, and the specific installation conditions may require adjustments to these ampacities. Several factors can influence the ampacity of a conductor, including the ambient temperature, the number of conductors in a raceway or cable, and the presence of other heat-generating equipment. Correction factors are applied to the ampacity values in Table 310.16 to account for ambient temperatures higher than 30 degrees Celsius or 86 degrees Fahrenheit. These correction factors reduce the allowable ampacity of the conductor to prevent overheating in high-temperature environments. Adjustment factors are applied when multiple current-carrying conductors are installed in close proximity, such as in a raceway or cable bundle. These adjustment factors reduce the allowable ampacity to account for the increased heat generated by the closely spaced conductors. Dating refers to the process of reducing the ampacity of a conductor based on these correction and adjustment factors. It is essential to perform dating calculations accurately to ensure that the selected conductor can safely carry the intended load under the specific installation conditions. To properly use Table 310.16, firstly, determine the conductor's insulation type and temperature rating. Secondly, identify the ambient temperature and the number of current-carrying conductors. Thirdly, apply any necessary correction and adjustment factors. Fourthly, select a conductor size that has an ampacity equal to or greater than the calculated load current, taking into account any applicable dating. It is always advisable to consult with a qualified electrician or electrical engineer to ensure that the wiring installation complies with all applicable codes and standards. Improperly sized conductors can lead to overheating, insulation damage, and potentially dangerous electrical hazards. Other relevant sections of the National Electrical Code that may affect the ampacity of NM cables include 310.15b3a, which addresses the neutral conductor in a 3-wire circuit, and 310.15b3c, which addresses the grounding conductor. The neutral conductor in a 3-wire circuit may be considered a current-carrying conductor in certain situations, such as where it carries a significant amount of harmonic current. The grounding conductor is generally not considered a current-carrying conductor, but it must be sized appropriately to safely carry fault current in the event of a ground fault. In addition to Table 310.16, other tables in Article 310 may be relevant depending on the specific installation conditions. For example, Table 310.17 provides ampacities for conductors in free air, and Table 310.19 provides ampacities for conductors installed in underground ducts. Understanding the different tables and sections of Article 310 is essential for properly sizing conductors and ensuring electrical safety. When working with electrical wiring, always follow safe work practices and wear appropriate personal protective equipment. Turn off the power to the circuit before working on any electrical components. Use properly insulated tools and equipment. Never work on electrical wiring when you are wet or standing in water. If you are not comfortable working with electrical wiring, hire a qualified electrician to do the work for you. Electrical work can be dangerous if it is not done properly. NM cable, or non-metallic sheathed cable, is commonly used in residential wiring for branch circuits supplying outlets, lights, and appliances. It consists of 2 or more insulated conductors enclosed in a non-metallic outer sheath. The most common types of NM cable are NMB and NMC. NMB cable is the most widely used type and is suitable for dry locations. NMC cable is moisture resistant and can be used in damp locations. When installing NM cable, it is important to follow all applicable codes and standards. The cable must be supported and secured at intervals not exceeding 4.5 feet, and it must be protected from physical damage. NM cable must not be installed in wet locations or where it is exposed to direct sunlight unless it is specifically listed for those applications. The National Electrical Code provides detailed requirements for the installation of NM cable, including minimum wire sizes, overcurrent protection requirements, and grounding requirements. It is important to familiarize yourself with these requirements before installing any electrical wiring. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical wiring from overloads and short circuits. These devices interrupt the flow of current when it exceeds a predetermined level, preventing overheating and potential fire hazards. The size of the overcurrent protection device must be matched to the ampacity of the conductor it is protecting. For example, a 15 amp circuit breaker should be used to protect a 14 American wire gauge NM cable that is rated for 15 amps. It is important to never install an overcurrent protection device that is larger than the ampacity of the conductor it is protecting. This can create a dangerous situation where the conductor can overheat and potentially cause a fire. Grounding is an essential safety feature in electrical wiring systems. It provides a low impedance path for fault current to flow back to the source in the event of a ground fault. This allows the overcurrent protection device to quickly trip and interrupt the flow of current, preventing electrical shock hazards. All electrical equipment and appliances must be properly grounded to ensure safety. The grounding conductor is typically a green or bare copper wire that is connected to the metal enclosure of the equipment and to the grounding electrode system. The grounding electrode system consists of 1 or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes that are buried in the earth. These electrodes provide a connection to the earth, which helps to stabilize the voltage and provide a low impedance path for fault current. Electrical safety is paramount when working with electrical wiring. Always follow safe work practices and wear appropriate personal protective equipment. If you are not comfortable working with electrical wiring, hire a qualified electrician to do the work for you. Ignoring electrical safety precautions can lead to serious injury or even death. Proper planning is crucial for any electrical wiring project. Before starting any work, carefully plan the layout of the wiring, select the appropriate materials, and ensure that you have all the necessary tools and equipment. Obtain any required permits from your local building department. Familiarize yourself with all applicable codes and standards. By taking the time to plan your project carefully, you can minimize the risk of errors and ensure a safe and successful outcome. Regular inspections are essential for maintaining the safety and reliability of electrical wiring systems. Electrical wiring should be inspected periodically for signs of damage, wear, or deterioration. Loose connections, cracked insulation, and corroded terminals can all create potential hazards. Any problems that are identified during an inspection should be promptly repaired by a qualified electrician. Regular inspections can help to prevent electrical fires and other electrical hazards. Understanding the basics of electrical wiring is essential for anyone who works with electricity. By familiarizing yourself with the concepts of voltage, current, resistance, and power, you can better understand how electrical circuits work and how to safely work with electricity. There are many resources available to help you learn about electrical wiring, including books, websites, and online courses. Consider taking a course in basic electricity or electrical wiring to improve your knowledge and skills. Always remember that electrical work can be dangerous if it is not done properly. If you are not comfortable working with electrical wiring, hire a qualified electrician to do the work for you. Your safety and the safety of others should always be your top priority. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest code requirements to ensure that your electrical wiring installations are safe and compliant. You can purchase a copy of the National Electrical Code from the National Fire Protection Association, or you can access it online through various subscription services. Many local building departments also offer training courses on the National Electrical Code. Staying informed about the latest code requirements is an essential part of being a responsible electrician or electrical contractor. In summary, understanding Table 310.16 and its proper application is critical for determining the ampacity of NM cables. Always consider ambient temperature, the number of current carrying conductors, and any other factors that may affect the conductor's ability to dissipate heat. Consulting with a qualified electrician and adhering to the National Electrical Code ensures safety and compliance in all electrical installations.